Under the radar of the press conferences and press kits, there's a set of Mars orbit data on 3i Atlas that still hasn't been officially released to the public. Imaging attempts and spectra that multiple mission teams have acknowledged are in the pipeline, including NASA's HiRISE camera on Mars Reconnaissance Orbiter and MAVEN's RUVS, along with complementary looks by ESA's Mars Express and ExoMars instruments. Officially, we're told those datasets are being evaluated, calibrated, or simply weren't optimal. Unofficially, the most concrete evidence we have comes from Europe, a short ExoMars trace gas orbiter sequence showing 3i Atlas as a faint moving point, our closest view so far from Mars, but leaving far more questions than answers. Stay with me, because by the end of this investigation we'll reconstruct exactly what we know, what's missing, who's talking, who isn't, and why the worst theory keeps growing every time a new image drops. And if you want more reporting like this, science you can verify, mysteries you can debate, hit subscribe, drop your questions in the comments, and share this with a friend who loves space but hates hand-wavy hype. The receipts are right here. Begin with the facts. On July 1st, 2025, the NASA-funded Atlas survey in Rio Hurtado, Chile, picked up a fast mover now designated C2025-N1 Atlas, officially 3i Atlas, the third interstellar object ever found, after 1i Oumuamua and 2i Borisov. Its path is unambiguously hyperbolic, an escape trajectory that doesn't bind it to the Sun, so by definition, it came from outside our solar system. That's not speculation. It's orbital mechanics, reconstructed from an observation arc now spanning weeks to months across multiple observatories. NASA's public brief pegs its perihelion, the point of closest approach to the Sun, around October 29-30, 2025, at roughly 1.4 astronomical units, just inside the orbit of Mars, with Earth never coming closer than about 1.8 AU. In other words, no risk to us, only an unprecedented science opportunity if we don't blow it. By early October, 3i Atlas slid behind the Sun from Earth's point of view and into the sweet spot for Mars-based observers. That's when ESA stepped forward. Between October 5 and 7, ExoMars TGO and Mars Express attempted observations. The release sequence from TGO's CaSSIS camera is short but telling. 3i Atlas appears as a faint moving point against background stars, no resolved nucleus, no flamboyant tail, but unmistakably there, about 30 million kilometers from Mars at closest approach on October 3rd. ESA published both a news note and an animated GIF. You can watch the dot move. That may sound underwhelming, but it's the first time we've caught an interstellar visitor with cameras that aren't Earth-bound or in Earth orbit while it skims the outer Martian neighbourhood. It's closest view in terms of vantage point, not image resolution, and that distinction matters for cutting through the social media noise. If you were following the feeds that day, you saw the collision of authority and expectation. Headlines called it a historic glimpse. The clip itself looked like a faint speck. That disconnect triggered exactly the discourse you'd predict. Where are the sharper frames, the spectra, the compositional fingerprints? Why not point HiRISE, the legendary Mars Reconnaissance Orbiter camera, and end the debate? Here's the nuance. Multiple teams have said, in various forums, that observations were attempted or are forthcoming. HiRISE, MAVEN's RUVS, Mars Express's HRSC and Omega, ExoMars' Nomad and ESEM, even the UAE's HOPE instruments and China's Tianwen-1 camera. But as of the time ESA published and mainstream outlets amplified the TGO clip, there were no comparable NASA Mars asset images in the wild, and certainly no public NASA-hosted HiRISE close-ups. That absence became the vacuum into which conspiracy thrives. Let's build the timeline cleanly, because in mysteries like this, dates are the first safeguard against narrative drift. Discovery, July 1st, 2025. Hubble constraint on the nucleus. Early August, published August 7th in a NASA science update, with a complementary apodee showcasing the July 21st, imaging and underscoring how fast this object is moving. Mid-July, Gemini and other ground-based telescopes produce crowded field images and pre-covery data that help refine the orbit. Late summer, the object brightens modestly. Amateurs and pros alike record the smudgy coma and short tail, confirming activity. October turns to 7th. ESA's Mars orbiters watch Atlas sweep past Mars, with ESA posting the CaSSIS animation on October 7th and an explainer about both missions participating. October 8th, mainstream coverage spikes. ABC News, BBC Sky at Night, Live Science, translating the ESA release into public-facing language. October 29th, 30. Perihelion, according to NASA's publicly posted ephemerides, at just 0.4 AU. That's the backbone. Everything else should connect to this. Now, the anomalies, real ones, with numbers. First, early activity at unexpectedly large heliocentric distances. Reports using Swift's UVOT identified OH emission, an indirect proxy for water, earlier and farther than typical for many comets, implying more volatile drivers or unusual thermal properties. If OH really pops strongly while still multiple AU out, you're either seeing efficient dust grain trapping of solar energy, unusually volatile ices like CO, or CO2 doing the heavy lifting, or a nucleus with high porosity and fresh exposures. Each of those points to formation conditions and processing history, not to alien engineering. But it's a genuine physical anomaly relative to the median comet. Second, size estimates span orders of magnitude because the nucleus is embedded in dust, and we're inferring size from coma brightness and assumed albedos. Hubble capped the upper limit around 5.6 kilometers while acknowledging it could be as small as a few hundred meters. That spread isn't a problem. It's a reminder of radiative transfer and phase function uncertainty. But it's the sort of ambiguity that fuels worst theory chatter. If you can't see the rock, people say, maybe it isn't a rock. Reality check. You almost never resolve comet nuclei at several AU without an in situ mission. Third, the Mars-based imagery is visually underwhelming compared to public expectation. A CaSSIS closest view that's a fuzzy dot doesn't satisfy our cinematic brains. But CaSSIS is optimised for colour stereo mapping of Mars's surface, not for tracking faint moving unresolved targets tens of millions of kilometres away. The instrumentation and observing geometry explain the imagery far better than any exotic hypothesis. The fact that Mars Express didn't publish a prettier picture simply means the object was too faint for its cameras at those exposure times and motion rates. Those are constraints, not cover-ups. Fourth, timing. Much of the US-based Mars fleet was expected to attempt observations. NASA public materials said as much. But anticipation is not data. In the interval when social media demanded, "Where's high-rise?" there were no released frames. That gave rise to NASA is silent. Silence in October didn't imply a shutdown or malfeasance. It likely meant pointing windows, signal to noise challenges, and pipeline realities. Several scientists publicly anticipated data from these instruments after the Mars flyby. That's a very different thing than promising public images on a specific date. Fifth, scale. Some outlets and influencers described Atlas as possibly the largest interstellar object yet, and tossed around 5 to 11 kilometre numbers. Others amplified more speculative claims of 20 kilometres. This dissonance reflects how upper limits and constant albedo assumptions get reported as hard sizes. The Hubble team's own language is cautious. Upper limit 5.6 kilometres may be far smaller. That's the sober centre. Treat anything larger as notional unless tied to a method and uncertainty bars. Sixth, trajectory-based hype. A handful of posts tried to link 3I Atlas's incoming direction to the historic WOW signal region, as if celestial coincidence equals causation. The orbit is what it is, retrograde, hyperbolic, inbound from the general direction of Sagittarius in a crowded galactic plane. The galaxy is filled with stars and dust along that sightline. Aligning a transient on the sky with old radio lore is cartography, not evidence. reputable explainers, and even contrarian scientists writing in public have stressed that the natural comet hypothesis is favoured by the data so far. Seventh, misinformation spikes. The more ESA emphasised closest view, the more certain corners of X, TikTok and YouTube insisted there must be sharper frames being held back, or that NASA had called it an alien mothership. Rebuttals from science communicators and fact-checkers came fast. There's no mothership, no threat trajectory, and image limitations are a matter of instrument design and target brightness, not a conspiracy. One popular science site even ran a piece titled, bluntly, "Ignore the nonsense," then aggregated real images to counterfakes. This is where institutional transparency pays off. When teams post raw or minimally processed frames with calibration notes, they starve rumour of oxygen. Let's examine the instruments and what they can reasonably deliver, because capabilities shape the story. Hubble's WFC3 + UVIS can track a fast-moving faint target by trailing the background stars. You get streaked stars, a point-like or slightly extended coma, and photometry that feeds dust production estimates. That's exactly what we saw in July. Ground-based facilities like Gemini North and South or Neue Labs International Network can produce crowded field images that, stacked properly, extend the detection arc and refine the orbit. NASA's Swift UVOT can detect OH emission lines that trace water breakdown, critical for assessing where water outgassing begins. From Mars, CaSSIS on TGO is a colour stereo imager for mapping the Martian surface. Its ability to catch 3i Atlas as a dot testifies to careful planning, but it's not a comet-chasing camera. Mars Express's HRSC and Omega are likewise tuned for planetary mapping and mineralogy. Maven's EVES can, in principle, detect ultraviolet emissions if the geometry and brightness cooperate. HiRISE offers exquisite spatial resolution near Mars, but its field of view, exposure limits, and pointing constraints make a faint, fast, distant comet a non-trivial target. If NASA ultimately publishes anything from HiRISE, expect it to look more like a photometric detection than a glossy magazine cover. The UAE's HOPE instruments and Tianwen-1's imager add potential cross-checks, but both missions prioritise their primary science. All of this is to say, the absence of a postcard is not evidence of absence, it's evidence of realistic SNR. How do amateurs fit into this? They're central. The Virtual Telescope project ran early streams. Backyard observers posted stacks that, while noisy, captured the coma and short tail. Those images, combined with professional photometry, traced a consistent brightening curve into September before the sun gap. The citizen science contribution here isn't just vibe, it's data that informs the MPC listings and the FITs that small body dynamicists use to refine non-gravitational accelerations. When people on social platforms say, amateurs are seeing more than Mars orbiters, the comparison misses the point. Amateurs were shooting in dark time with instruments designed for exactly this sort of low surface brightness target, while Mars orbit cameras were opportunistic off-label observers. Both streams are credible in their own lanes. Now, the worst theory. In every interstellar object cycle, a minority of voices argues for non-natural origin. Oumuamua brought solar sail speculation, then Borisov pulled the conversation back toward icy comets. 3i Atlas has already attracted think pieces from prominent contrarians who have, to their credit, also emphasised that a natural comet remains the leading explanation. The point for us isn't to dunk on alternatives, it's to weigh them the way a PhD committee would, with priors, predictions and discriminating tests. If Atlas were engineered, we'd predict coherent non-sublimative forces acting on the trajectory, narrow band emissions inconsistent with known cometary species, or morphology changes decoupled from heliocentric distance and phase angle. Instead, we see coma growth, dust production, and a tail consistent with solar radiation pressure. So far, so comet. Put bluntly, extraordinary claims, ordinary evidence. Institutionally, how have the players behaved? ESA moved quickly and publicly. Short notice, modest imagery, clear explanation. NASA's Central Science page has been updated steadily with high-level facts and observing plans, and Hubble's team published constraints promptly in August. Media partners from ABC to the Planetary Society contextualized the releases and tamped down the notion that closest view would mean a cinematic flyby. Where communication faltered was at the interface with public expectation. Announcements that NASA's Mars fleet will attempt to observe were read by many as promises of spectacular pictures. When those didn't materialize on social media's timescale, suspicion bloomed. A more proactive cadence, posting even null results or limits, would blunt that effect. And don't underestimate the power of simple language. We tried. Here's why it's hard. We'll post the raw frames if they're scientifically usable. That's how you prevent the missing data narrative from metastasizing. So what do we actually learn from the October window? First, the Mars Vantage confirms geometry and brightness evolution consistent with model predictions. A faint, unresolved coma at tens of millions of kilometers, brightening as it heads toward a 1.4 AU perihelion. Second, even modest image sequences tighten the astrometry. A few pixels of motion against background stars on a precisely timed platform are gold for orbit refinements. Third, the lack of dramatic structure in the CaSSIS clip argues against large, detached fragments, or obvious jets at the observed scale. Non-detection is a result. The October data, in other words, reinforce the baseline comet model and leave the door open for composition work as perihelion approaches. What's next, and what would count as a real break in the case? If Swift-class UV detections strengthen as Atlas closes in, we'll map out the relative roles of H2O, CO2 and CO in driving activity. If ground-based IR spectroscopy catches carbon-bearing volatiles at characteristic bands, we'll get a handle on the ices. If not, we will at least constrain them. Post-SunGap, large telescopes with adaptive optics could pick out faint asymmetries in the coma, indicative of rotation and jetting. And if any of the Mars orbit instruments do release calibrated frames or spectra, we'll have crucial cross-platform consistency checks. A different vantage, different phase angle, comparable photometric trends. Watch for compositional papers from teams that have already published on Oumuamua and Borisov. The comparative angle is where new physics hides. Let's talk public discourse, because this channel is as much about media literacy as it is about astrophysics. When you see closest view in a headline, click through and ask, closest in what sense? Distance, not resolution in this case. When you see size claims, ask for the method, direct imaging of the nucleus, or inference from coma brightness with assumptions. When you see NASA is silent, check official pages and mission feeds for observing plans, and be aware that calibration and quality control take time. When you see someone splice a noisy amateur stack into a narrative about hidden tails or strange shapes, look for the processing notes, stretching, stacking, star trail subtraction. These aren't pedantic details, they're the difference between science and storytelling. And yes, we're storytellers here, but we're accountable storytellers. History helps. Oumuamua's light curve anomalies and non-gravitational acceleration created a vacuum that theory rushed to fill. Borisov then arrived as the palate cleanser, a down-the-middle comet with carbon monoxide richness that told a clear story about formation far from a parent star. Atlas seems closer to Borisov than Oumuamua in its presentational behaviour, coma, dust, a tail consistent with radiation pressure, and yet it may still surprise us if outgassing shifts regimes near perihelion. That's where anomaly stacking is powerful. We list the small weirdnesses, early OH, wide size bounds, faint Mars Vantage imaging, and see if they stack into a new category or dissolve when better data comes in. Right now, They don't stack into the exotic column. They stack into interstellar comet, interesting volatiles, challenging to observe from Mars. Why the worst theory grows with each new image is, ironically, a product of modern transparency. Each time a sober image drops, a faint dot, a smeared streak in a crowded field, it collides with the cinematic mental image we all carry. The gap between expectation and reality needs filling, and if institutions don't fill it with calibrated plots and plain English explainers, someone else will fill it with speculation. ESA's brisk release of the CaSSIS clip, paired with an explainer about why it looks the way it does, was a model move. NASA's strengths, the Hubble size paper, the stable facts page, are excellent anchors. The missing piece is synchronized cadence across agencies and partners, especially when public announcements promise attempts on specific dates. That's not just media strategy, it's scientific hygiene in the age of algorithmic rumour. Let me plant a flag on what would genuinely change my mind. If post-perihelion photometry showed a sustained direction-locked acceleration inconsistent with a dust or gas-driven rocket effect, if narrow-band emissions lined up with no known volatile, if high-cadence imaging revealed rigid body-like curves inconsistent with coma-dominated photometry, or if an in-situ probe returned engineered materials, then the non-natural hypothesis would move from tabloids to journals. Short of that, every new closest view that still looks like a smudgy comet is another brick in the wall supporting the mainstream model. That's not dismissal, that's discipline. You asked for the social layer, so here's the temperature check. On X, the biggest engagement spikes followed the ESA release, the GIF circulating with captions ranging from awe to derision. On YouTube, skeptical explainers debunked mothership claims and aggregated real imagery. Their comments are a mix of curiosity and frustration about NASA's cadence. On Reddit's astronomy forums, the highest-rated answers were patient instrumentation explainers. The through line is simple. When experts show their work, exposure times, tracking rates, expected SNR, communities respond with trust. When institutions let rumour outrun releases, the vacuum fills with the worst theory. So, where does this leave us as 3i Atlas swings through perihelion and back out into the dark? With an interstellar comet that behaves like a comet, with some fascinating volatile hints, with a multinational observing campaign that is, inevitably, messier at the edges than the press releases imply, with an ESA clip that's scientifically modest and historically meaningful, with NASA pages that ground the public in basics, distances, dates, threats, and Hubble constraints that do real work on size and dust, and with a social conversation that's loud, creative, and often wrong, but also hungry for the kind of transparency that science can and should provide. Here's my ask to you, the community that actually reads to the end. If you see a claim about 3i Atlas, ask for a method. If you see a number, ask for a unit. If you see closest view, ask by which metric. Drop your questions below. I'll pin a comment with links to the latest raw frames and papers as they post. And if someone tells you the worst theory grew because the latest image was too faint, invite them to learn how faint targets get measured, how a dot can rewrite a textbook, and why, sometimes, the most honest picture of a thing from another star looks exactly like that. A travelling point of light across a patient sky. If you want me to extend this into a full 60-minute voiceover, I'll keep layering in the perihelion data, the first post-sun gap spectra, and any Mars asset releases the moment they're public. But even now, if you know where to look, the story is there. A visitor from somewhere we cannot yet name, carrying dust we have never breathed, crossing a field of stars we will never reach. It's not a mothership. It doesn't need to be. It's better. It's evidence. Hard, stubborn, beautiful evidence that other solar systems shed pieces of themselves, and sometimes those pieces wander into our cameras and ask us to be worthy of the view. Sourcing. Highlights used in this investigation include NASA's 3i Atlas overview and Hubble nucleus constraints, ESA's ExoMars Mars Express release, and CaSSIS animation, APOD documentation of the July imaging, the Planetary Society's explainer, live science, and ABC News translations of the Mars Vantage observations, swift UVOT oak reporting, BBC Sky at Night's instrument roundup, and public Q&As by researchers discussing expected Mars asset data. If new, peer-reviewed measurements materially change any claim made here, I'll annotate and update this script so it remains a reliable reference for classrooms, skeptics, and late-night rabbit holers alike. Now tell me in the comments, what's the single piece of data, instrument, wavelength, or geometry you most want to see to nail down Atlas's composition? And if you've captured it from your backyard or your lab, I'll feature your work in the next episode with full credit.